afternoon, everyone. Can you hear me, Jamie? Fantastic. We will make a start. People can join in as they go. Good afternoon, everyone, and welcome to our Friday webinar. Today, we're continuing to look at custom tables. By the end of this video, you should know as much about custom tables as I do. Specifically, we'll be creating another custom table that allows us to apply machining for hinges to ends and doors when we want more than 5 hinges in a door. Last week, we looked at a table that allows us to apply a single hinge and position it based on local properties. This week, we are applying one where we can put in the quantities as we please through another local property, and we can put in as many hinges as we want per door. And as you can see, it will apply the hinging and the hinge plates and space them evenly. As with last week's webinar, we won't be doing questions on custom tables. You can leave the webinar at any time by clicking on the red phone button at the bottom of the screen. As I said earlier, we're jumping right into writing tables today. If you need more background on how custom tables work, you can watch our previous webinars. You'll find them on our YouTube channel. The end result of today's custom table is that you can add as many hinges as you want. This video will also be going onto YouTube, so you can always go and watch it there next week. So let's start with hinge plates. In the previous video, we made a table that repeats a 5mm hole with a 32mm spacing, which is what we'll be doing one of these lines with. This time we're going to have 2 different sets of 5mm holes, and they will repeat by the quantity that we define, and they will space automatically based on the height available, but each line will be offset by 32mm. So it will give the appearance of different hinge pairs or hinge drilling. We're going to start by copying and pasting our sample. So again, copy that, paste that in there, and we will rename it to more hinges. And it will be just there. So we'll open that up. The first thing to do is determine which end the plates will go in. After we go and delete everything in this table, we'll just delete all that. And we can use a formula for that. We've been over these formulas before in the previous video. So line 1, I'm going to go if sec part name equals E&L close bracket, then 1 else 0. So that's if it's end left, be on, otherwise be off. And I'm going to copy and paste that, and we're just going to put it into line 2. The layer can be hinge plate, and it has to be in quotation marks. And we can copy and paste that down there as well. So we are going to do at the moment line 1 and line 2. So this is line 1, this is line 2. Just so you're following along with what I'm doing. The diameter is 5mm and the depth is 13mm. We're doing it based on the Bloom pattern. Again, if you're using different hinges, something like this doesn't need to be hinges. You can use this for whatever you want. You could use this to make pegboards, all sorts of things. What it will do is just evenly space the machining accordingly. The X value is easy for the left end. it's just going to be 37 millimeters. So that is to the center of the hinge plate hole. For the Y value, we want to start the first hinge with, say, 100 mil center. I'm already going to change this to string because this will change in the future. But for now, we'll set that as 100 mil, and we can do that one there. And we have 100 millimeters there. Now that is 100 mil to the center of the hinge plate. So if we're 32 mil spacing, so it's 16 difference, so we can go negative 16 millimeters, and it should calculate. It didn't because it's a string. If it was a length, it would. There you go. And that one is going plus 16 millimeters. So we have those. For repeat quantity, for each, we need this to be a local property where we can define how many hinges we want. I'm going to use define 12. So if we go into my setup, local properties, you see I already have it ticked on. I'm going to leave it as X12. So as we're looking at it in here and in the cabinets, we know that it is define 12. Back into there, and the repeat quantity can simply for now be define 12. And it needs to be a string, otherwise it shows as an error. Define 12. Copy and paste that one down to there. We're not doing any X repeats in this table, so this column can just stay blank for the entire time. Repeat Y, and this is where we need to calculate how the hinge plate is going to repeat, or how each part of the hinge plate is going to repeat. So we want the table. The formula we enter in here can be used for the Hinge Cups and Hinge Lugs in this table too. So if we get it right, then we could just copy and paste when it comes time to do those. And most of the setup is done in these first two lines, and then there's a lot of copying, pasting, and changing a couple of numbers. So we can calculate the repeat distance by saying the height of the divided part divided by the quantity of hinges. Now we know last week code my is the height of the part, so our formula would be code my divided by our repeat quantity. So that'll be define 12. And again, that needs to be a string. Code my divided by define 12. We can copy and paste that into there. And of course, Z is going to be 1. 513. We'll double check all our numbers. That looks good. So we can go File, Save, close that down. Now I already have a custom table applied with that name, so I don't need to go and set all that up, but we can refresh that. Open it up. I'm going to turn off the part view there, and we can see that it is applying now what appears to be hinge pairs, but the actual group is the bottom of each hinge plate and the top of each hinge plate. So what we can see is that it isn't actually applying hinge plate from the distance from the top, so we need a separate hinge plate machining to do that. We'll do that with line 3. So we can open up our table again and copy and paste line 2 into line 3. Just Control C, Control V. And the Y value will be code in Y minus 16 millimeters, because that is the top of the door less 116 millimeters, and this is where it needs to be string. So we can do that. Repeat quantity, because we are just doing this top hinge plate, is going to be 2. So that can change to a 2. And our repeat Y will be 32 millimeters. And of course, Z will stay as 1. Now, at the moment we have, if we look at our quantity, we have 6 there, and we have 1, 2, 3, 4, 5, 6. We're adding in another hinge plate up here that will be calculated separately, but we want it to be included in that 6. So we can essentially say define 12 minus 1 for each of those. And that way the top 2 lines will calculate what we're wanting. File and save. So if we close that, cancel that, and refresh, if I did this right, we should now have our hinge plates there. I'll open this up so it's a bit easier to see. We have 1, 2, 3, 4, 5, 6, and you can see at the moment they are not spacing evenly because we haven't accounted for the distance between that hinge and that hinge to the top and the bottom. So we can go back to our table and open it up again. So what we need to do is change the rep Y column, and to make it a bit clearer, we'll put that in brackets. Now, the custom tables, they work as BODMAS, which is brackets of multiplication, subtraction, multiplication, division, subtraction, addition. Make sure that you use brackets though, so that it all calculates correctly. So we want code in Y, which is the height of our door, minus, for now, 100, which is our hinge center. And then we can go minus 100 for our bottom hinge center, close bracket. And we should probably make them in millimeters and put a bracket at the start of that. So is all that divided by that. And we'll go file and we save, and we can close that, back to the drawing, refresh, yes. Open it up, and we can see that we now have 6 evenly spaced hinges or hinge plates, and we can change the quantity in there and it will adjust accordingly. So I'm going to put that back to 6, tab, apply and OK. So we are really close to being done on the hinge plates. All we need to do is tell it when it's a left end or when it's a right end. Now there's multiple ways to do this, and we can shorten these codes down, but I'm going to write them longhand because they're easy to see easy to understand. So in the use column, I'm going to drag that out a bit. And we're going to change this to remove the 0 and add in if sec part name equals ENR, close bracket, then 1, else 0. So this is basically saying if it's an N left, then be on. Otherwise, if it's a right, be on. Otherwise, be off. And it's very important that you get the spelling in these formulas correct, otherwise it won't work. And then in the X column, we'll change this to string. And in here, we can determine if it's a left end, then it will be 37 mil. But if it's a right end, then it'll be the width of the part minus 37 mil. So we can turn that into if sec, we need to put that in brackets, always put in brackets, sec part name equals ENL, close bracket, then 37 millimeters, else codim X minus 37 millimeters. And we can copy and paste that into all three. So we'll file and we'll save that. We'll close it. Back in CabMaster, we will refresh. And there it is on our right-hand end. So back into our table. Now, what if we don't want the top and bottom hinges and plates to be fixed at 100 millimeters? What if we want to be able to see them in or set them based on the cabinet properties? If we go to cabinet machining and then hinge, we can see that we have hinge center distance and we've got top and bottom. If we hover over those, we can see that it says Mac hinge dist top, and hover over that one, Mac hinge dist bottom. We can use these codes in replace of a fixed value in the Y column. So instead of having these fixed values, so for line 2, sorry, we'll start with line 1. We can go with Mac hinge dist bot minus, now we're going minus 16 mil because it's the center of our hinge down 16 mil, or center of our hinge plate down 16 millimeters. Put the measurement in there. We can copy and paste that into there. And this one we're going plus 16 millimeters. And then we can copy and paste that one. And of course, line 3 is our top hinge. So we can just change that to top. Then in the repeat quantity, we need the to replace the 100 millimeters with these two each. So that would end up as Mac hinge dist bot, and this one here would then be Mac hinge dist top. And again, it is absolutely vital you get that spelling correct. We'll copy and paste that into there, and we'll very quickly see if we got that correct. When we save and close and refresh our drawing again, nothing disappeared except our top hinge, and that disappeared because I didn't have the CODIM Y minus, so the height of our door, minus the top hinge distance. So we can save that, close that back to there, and F5, enter. And there's our top hinge, and as you can see, they're set at 200. If I change that back to 100, we now have our hinge plates that can move up and down, and it will space the hinges between accordingly. So that's our hinge plates done. We can take what we've done with our hinge plate holes and do something exactly the same with our hinges. So first thing I'm going to do is open up our table again, copy and paste line 3 into line 4. Now this is going to be our hinge lugs, so we'll change the layer to lug, and it's an 8mm diameter as per Blum's drilling pattern. And we also need to change the use column code. Now I'm just going to delete out quite a lot of this. Make sure we get the spelling correct. And instead of being an ENL for end left, we change it to DOR for door. So this way, it only applies to the doors. And then we need to determine whether it's going to apply to a left door or a right door. We need to use the code if hinge me on right, then 31, otherwise CODIM X minus 31, because 31 is the distance to the center of the hinge. So we go if hinge me on equals right, then 37mm becomes 31mm, else CODIM X minus 37mm. We used this same code last week. If you need a better explanation of what this code is, you can watch it in that video. So essentially, with these two codes, we can say only apply to doors if it's a right door or if it's swung off the right end of the carcass, be 31mm. If it's swung off left end of the carcass, be the width of the door minus 31mm. And that brings it back to, if I close that down and go to our hinge light, it is 37mm. If this was a right door, it would be CODIM X, which is this side, back 37mm or 31mm in this case. It's a hinge lug. Let's save that. Now, we also need to apply or change our quantities or our distances. So in this line here, we're going to have, this is going to be our top one. So we go negative 22.5, which is the distance between our hinge lugs. So it's 45 from there to there, so we're going halfway, which means this one here, our repeat Y would be 45 millimeters. File and save. So we can close that down. Back in CabMaster, open that up, give it a refresh. And we can see that we have Hinge Lugs. Now the reason it's done this is because we currently have door gaps. We will deal with that at the end of the video. But for now, when there's no door gaps, we can see that our Hinge Lugs line up at the top with our Hinge Plate holes. So we can go back and continue editing the table. Okay. So we can copy lines 1 and 2 into, so Control C, click on 5, Control V, into lines 5 and 6. And we can quickly change these ones because we already know it's 22.5 to negative 22.5. This one here will be positive 22.5. We can copy and paste that one into here and copy and paste this one into here. And this one down to there, and our diameter, make it all the same. We could have probably copy and pasted line 4 into 5 and 6 and then just copy this code across in these ones. Same destination, different way to get there, and we can save that. Back to CabMaster, we'll refresh that, and we can see there is now all our Hinge Lugs applying accordingly. So we'll go back to our table and open it up. So now we just need to do the Hinge Cups. Close that. So the first thing I'm going to do is copy lines 4 and 5 into lines 7 and 8, and they will be our 2 Hinge Cups there. So we want 4 and 5 into 7 and 8. So line 7 will be for the top hinges. So first we change the layer to Hinge Cup. We change the diameter to 35 millimeters. And we replace the 31s in the X column to 21.5. .5, because that is 21.5 from the edge of the door to the vertical center of the Hinge Cup hole. The Y value for line 7 doesn't need to be offset anymore because it is the center. So we can remove the 22.5 there. It's not getting repeated, so that can go back to a 1, and the rep Y can be removed. Line 8 is the last line that will be in this table, and it also needs to be Hinge Cup, 35 millimeters, the same X value. Again, we can remove the 22.5 Now it's the one that's getting repeated, line 8, so it will stay repeated and it will have the same repeat quantity. So we can go File, Save, close that. We'll refresh our drawing. Click the wrong button, enter, let it refresh. Open up our cabinet, and we can see now we have all our Hinge Cups. You could stop here if you wanted to. If you don't want to account for door gaps at top and bottom, and if you don't want to be able to do different things with layer names, this is where you could finish. What I do want to show you at the moment, or now, is alternative methods for layer names. So currently, we just have them Hinge Plate, and if we look at the door, Hinge Cup and Hinge Lug. What if you want the layer name to calculate based on the diameter of the hole though? Close that. So instead of Hinge Plate, it would be Hinge underscore 5 millimeters, or Hinge underscore 8 millimeters, Hinge underscore 35 millimeters. We can replace the layer name with that string there. So if we open up our table again, we'll open that right up so we can see what it's doing. And this has to be entered absolutely spot on. So we go Hinge underscore, we have that in quotation marks. And machine step, then we have a square bracket, custom B underscore 1, close square bracket, we'll stop there, and then radius, depth, suppress, at, also in square brackets, dot x star 2. Now, if I got this right, we can put that in all of those. We can save that and we can go back to our drawing, refresh it again. And get rid of the door gaps, because we'll come to that in a minute. Tab, view our machining. And you can see we now have Hinge underscore 5 mil. We change it to upper door. We've got Hinge underscore 35 mil, and our lugs are Hinge underscore 8 mil. So the last thing I'm going to do today is account for door gaps at the top and the bottom. We know from last week that the code for door gaps is door gap top and door gap bottom. These can be used in formulas. So in the Y value of the top hinge cup, which is line 4, no, top hinge cup will be line 7. And lug machining, we need the plus door gap top for lines 4 and 7. In the Y value. So in here, line 4, we come across to line 7. 3 row column Y in line 4, confusing myself. And we go plus door gap top. And we also put that into line 7. Plus door gap top. For the other hinge cup and lug machining, we need to include minus door gap bottom, and that is in lines 5, 6, and 8. So it'll be minus door gap bottom, line 6, door gap bottom, and in line 8, minus door gap bottom. So this will offset the hinge cups and lugs by the door gap amount. The last thing we're going to do is change the rep Y column so that it also accounts for those when it calculates the distance between our hinge lugs and our hinge cups. So in here, we're going to add another bracket. And I'll quickly show you what that code looks like. That is it there. So that is our code that we'll be using for this. So we're adding in the door gap bottom plus door gap top in brackets. So it's the height of the part plus our door gap top plus our door gap bottom, which gets us back to the height of our carcass, minus the distance to the center of our top hinge, minus the distance to the center of our bottom hinge, and then divided by how many hinges we want, minus 1. So we can go into here and we can start typing all this in. We go plus door gap top, door gap bottom, close bracket, and we should be able to copy and paste into all of those, and we'll double check. So it's code MY plus door gap bottom or door gap top. That's all spelled correctly, and it's in brackets. Minus machine hinge distance bottom, minus machine hinge distance top. Perfect. Save that, close it, and we'll refresh CabMaster one more time. And as you can see, I have calculated something wickedly wrong. So we'll go back to here and we'll have a look and we'll see what we have done. So our Y value is bear with me a minute, sorry. This is why it's absolutely vital to get all your code and calculations correct. So what it appears to be doing is offsetting it's our hinge plates that are actually incorrect. It's quite probable that we don't actually need that section there. File and save, exit. And that is it there. And as you can see, that's why it's absolutely essential to double check your codes and break down what it is doing. Hinge plates don't need to account for door gaps. because they're calculating off the height of the carcass or the carcass end itself. So we now have, refresh one more time, a working table that accounts for our gaps. That could be -500. That could be 0. And it will continue to line up our Hinge Cups and Lugs with our Hinge Plates. And we can change the quantity based on our local property. And then, of course, we can change our hinge positions to whatever we want. And it will space the hinges in between evenly. Now, of course, this table is written at the moment to only work with 2 doors on the cabinet, so a left and a right door. It's always going to apply machining for the hinge plates to both ends. If you wanted to know how to change the machining to only apply to an end if there is a door swing on that end, go back and watch our previous webinar video. It has the code in there. It'll be very easy for you to work out, and you can start having a play around with custom tables and working things out for yourself. So I hope everyone now understands or has a greater understanding of how custom tables work, what they can do. It's all very much the same. Find a code in CabMaster or find anything like this in CabMaster. You just hover over it. You can see those codes pop up if you've got Machining Premium, and you can start writing these custom tables and creating your own tables and making your own CabMaster better, and put the Pro into CabMaster Pro. Have a good weekend, and thank you for joining me.